Let me see if I can find.
She was like, I didn't get the invitation. Miss Hutchins arranged it.
And then when I said something to her about it, she didn't ask nobody in class.
Right. And I was like, and I told her, I was like, Malaysia, you making a big deal out of her. She made me mad. And I was like, you're right. And I was like, you be saying this, you don't. Damn, but yeah, you be everybody's face. And I was like, I told her, I said, me and Allison was like, you got issues. And she's like, no, I don't. And I'm like, you be isolating yourself and acting like you ain't got no friends, and you got friends. And I was like, you can't have those. But then,
All right. Find the one that looks like this. It's the one that has two graphs on the same side. Okay? Find the one that has two graphs. It's the top one. All right, we're going to do this one together. And then I'm going to let y'all do some on your own. All right, so you're going to find four quantities for me because you don't know what I'm going to ask for on the quiz Thursday. All right, so EA reverse, delta H, and delta H reverse is what you got to be able to find. Because I'll ask for any of those four. So, how do we find activation energy? Well, the first thing you got to be able to find is the reactants of the products. Where are the reactants at? What number?
0.
They're at 0. Is everybody okay with the reactants? Always start at the beginning of the graph. Where are the products always at? The end. Everybody okay with those two facts? Okay. Now, activation energy goes from where to where? The reactants to the top of the curve. All right. So, change colors here. From the reactants, which are at what number?
0.
To the top of the curve, which will be what number?
100.
Now, we're not going to estimate 95 or anything like that. We're just going to go whole numbers on this. All right. So, 0 to 100. So, what would be my activation energy? 100. Everybody okay with that? Okay. Now, reverse activation energy has to go from where to where? The products to where? Top of the curve. So there, all the way up to there is reverse activation energy. So, what amount is my reverse activation energy? Now think before you yell out anything dumb. Okay, hold on. That's why I'm telling you to think. You're on a number line. You're going all the way from down here all the way up to here. It's 250. Okay? 250.
It's only going to be positive and negative on the H's, right?
It's only going to be positive and negative on the delta H's. That is correct. Okay? Your activation energy is always a positive number. You're counting how far you moved on the number line. You went from negative 150 to 0, which means you moved how far on the number line? You moved 150 kilojoules. And up here, you moved how far? 100 kilojoules. So you moved a total of how far on the number line? You moved 250. And all of the graphs won't have negative numbers on them. All right.
Is that kilojoules or moles?
Yes, kilojoules over moles. The unit's right here.
They look like moles.
Oh. So, for delta H, we go from where to where?
You go from something to something.
Yeah, I know I go from something to something. What's the something to something?
It's the products minus the reactants.
All right, so the products are at what number? So we go from the reactants to the products. Now, before we even figure out the number, what can you tell me about this reaction? Is it endo or exo? How do you know it's exo? Products are lower. It means it's exothermic. So if it's exothermic, what can you tell me about delta H? Delta H is negative. So I'm going to put a negative right there, which means the reverse is going to be what? Positive. Now all we need are the numbers. The numbers will be the same for delta H. So what's the difference? Again, it's the number line. Don't yell out anything dumb. We're going from 0, where the reactants are, to what, where the products are? 150. Are we okay with that?
Yeah.
Stephanie's died on her paper.
Are you okay?
You getting what Xavier's got? Y'all might want to move away, by the way. He says his stomach's really bothering him. I'm just saying. All right. So I want you to do the second one on that page right there, right in front of you. All right. The one that looks like that. Same three things. EA reverse. Okay. You're finding EA reverse, delta H, and delta H reverse. Oh, let's see if the attendance is loaded. Jaden's paper's finally dried.
Does delta H have?
Yeah, same unit. All under the same unit.
Does that reach 80 or below 80?
That's 80.
80.
We're just gonna estimate.
We're just going to estimate the whole numbers. That's why I told you that, just to make life easy on us today. Otherwise, I get a bunch of 78, 75s and weird numbers.
I want to know the secret too. Text me too. I want to know the secret.
Yeah. Because I'm bad at whispering and I'm bad at somebody whispering to me.
I can't read lips.
Me neither. I can to an extent. Like certain stuff is like me and Allison, we can carry on a certain conversation, but then she be using big words. I'm like, all right.
You
All right, got it?
cannot mouth no.
All right, so EA goes from where to where? EA goes from,
It goes from reactant to the top of the curve.
so 0 to what?
80.
So EA will be,
80.
okay? And EA reverse goes from where to where?
50.
Okay, the products to the top, which will be, what did you estimate, 50? That line is terrible. All right, 50 to the top, which would be 50 to 80, so 30? Okay. All right, was this graph endo or exo?
And
How'd you say it was endo?
products are higher.
So that means delta H is what sign?
Positive.
So reverse is,
Negative.
okay. So what are the products at?
0.
The products are at 50 and the reactants are at? Reactants are at 0. All right, so 50 to 0 makes the difference? Yep. So positive 50 and negative 50 kilojoules per mole on both of them. We feel good about those? All right, do the back side.
You're just showing off her tattoos.
So with the delta H and
Yeah, we need to.
Could it be the same numbers?
It
plus
don't like
the
the
negative?
stencil.
Yes.
Feel like it
You want us to find the same stuff for the.
Same stuff for the next three, yes.
Oh.
I will be shocked if you do not see one of these on the exam, which is why we're doing them. And then we need to talk about catalysts when we finish these three. Do not let me forget catalysts.
No, thank you.
Everybody let her forget catalyst.
No, because then if it's on the exam, you won't know the answer.
Oh, well.
You also want to know if it's endo or exo.
You only need to know if it's endo or exo for the purposes of the number, which is why I keep asking.
So we don't have to write it down.
You don't have to write it down.
Factual.
Are
you making a bracelet this
No, I'm putting these beads in the
It looks-
bags. I pull the nucleus out of the models and recycle the beads, but
Let's
I'm
have
just doing little rings.
No.
Why?
Her arm.
Is it cool?
Yeah, I was thinking that too.
I was talking to my mama yesterday about getting another one. She was like, please, Shannon, no more tattoos.
20,
You have a tattoo.
40,
It was long.
60,
Come on, it's just a mark.
80.
You want to see it?
No, we don't.
I'll show you a picture. No, we don't. Where's our phone?
Behind you.
Who else has one?
I got one. I got two.
You have one in like your arm?
Yeah, I got one right here and I got one on my back.
And then Allison got one. And then that's it.
Does it hurt? Did it hurt?
The one on my back hurt so bad because I got this bone that popped out. Oh my god.
Mine didn't hurt. I thought it would, but
Oh yeah, I got moves for us tomorrow.
where we going? Where we going?
Yeah,
Actually, tell.
Shh. Gee. Hey, you finish those graphs.
Yeah.
you gotta look cute.
You and I both know you have not.
How do you know?
Because you're sitting over there scrolling through your
Why you in
phone.
my business?
Your
That's
business.
none of your business.
Mind you, you're showing me the pictures of your boobs on your phone.
It took him like 2 minutes, bro. I was scared. I was. It didn't. But it was, you think it was the other one because of that? I don't think so.
May I see?
Everybody was like, why did you get it filled in? Because, why would I get it filled in?
Yeah.
That shading would be a killer.
It's your
That's right
tattoo.
there.
Tonight, she liked the way the chicken feel better than that one.
Really?
Shading hurts.
Right, because everybody I talk to, they talk about shading is the worst part.
No, a lot of people say shading is the
Do you
worst
have any
part.
tattoos before?
Nope. I like needles.
What about you?
I don't like shots, but
Yeah.
Right. I hate shots. I used to cry when I got shots.
I was gonna say, have you been up there?
You funny.
Oh, my God.
You're going.
What about you, Simone?
Not playing.
What?
Not playing.
Bye, Jay.
Why not?
I didn't know they went.
No.
All right, we done?
Right. You just said it out loud.
You went to,
Maybe you need to sit further away from me.
You said what now?
you went to go poop.
You're ready to throw up.
Oh, my God. She's stupid.
You go throw up.
Go home. Right, go home.
Leading up to this way.
Yeah, you need to get down.
Call your mama and tell her that
You got throw up sweats too.
throw up sweat.
Yeah.
Are you cold?
Oh.
You cold?
You got any mask?
You need to try to get my use.
Yeah, put a mask on. Put a mask on. He's infecting our air.
How funny.
Good thing the vents circulate our air.
Don't throw up in this.
Eh.
I actually do have one.
And don't touch
Put that
yours. Okay. You got some gloves.
I don't have any gloves, but I at least do have that.
They gonna contaminate you. Put your form.
All right, so if we look at the first one. All right. He actually just went through up. He won't go home.
I'm sorry to interrupt you. I just need to ask one quick question. This mom just called and said she'll be here in 45 minutes to pick up any missing work. She has poison ivy, and she's not sure how many days she'll be out.
Okay, she missed a lab yesterday. I can give her a couple worksheets that go with what we're doing, and she can watch it online. And I know she actually does do this. I'm thinking do that.
I didn't know where you were.
You do that Friday? She did Friday?
No.
She missed that. She might have missed.
What she is her
You send that
job?
I just did this.
Yeah.
Kiana going to
I was about to say, yeah, you gonna mess it up for her.
We'll do that.
Cause I know you have, definitely have.
I want to be like you when I grow up.
I'm just going to Learn a little bit more.
Stephanie, are you sick too?
Some of this is going to be fast.
Stephanie, why you pop up like that?
She is going to need.
That was not.
They all had some favor of this.
So, later when you're not sick, but I have to see for you.
That will probably push us into early next week. So hopefully she will not need all that stuff.
Thank you so much.
You're welcome. All right, looking at what you got on the board, because everybody should have had time to finish. So if we look at EA, what'd you come up with if you start here and go here for EA? You got what?
Oh,
Now, y'all can try not to sound illiterate over there. You got what?
100.
Okay. I thought I was at West Davidson for a minute. You know, I'm used to those kind of answers when I ask people stuff out there. Only when they want to sound stupid.
At West Davidson?
Right.
I see that.
I don't see that.
All right, so we have from -20 to 80 would be 100 because you've got 20 here and then you've got 80 more. Is everybody okay with that answer? Nobody said 80 minus 20 and got 60, right? Just checking. All right, so from there, reverse would start at, do we estimate 60? Sometimes I get really weird answers on this one because they all estimate like 50. Remember I told you, use the whole numbers. So start at 60. So 60 to 80 would be 20, okay? If you actually did like 50 to 80, your process is right, but sometimes people look at that a little odd. All right, same thing for delta H. Delta H would be positive or negative here? Positive, it's endo. Okay, because it's higher, so positive. Delta H reverse will be negative. And what number did you come up with? You start at 60, and you go all the way down to -20. It's going to be what?
80.
It's going to be 80.
Well, I got the numbers
I
right.
did right.
You just had the signs backwards?
Yeah.
Do you see why?
If
Do you see why they're what they are?
yeah, so products are higher than delta H is positive.
Yes, because it's endothermic.
Okay.
Yes. Okay, and the units will be kilojoules per mole on that one too. All right, so on this one, when you look at this, all right, delta, or let's do E first. All right, E, A is what? Well, I know you were in the bathroom being sick. I don't have time to wait on that. All right, 0 to 20 is 20. EA reverse is what? -40 to the top would be 60. Delta H is positive or negative this time?
Negative.
All right, delta H reverse is positive. All right, so what did we get for a difference? 40. -40 and positive 40. All of them are kilojoules per mole. All right, and the last one. EA would be what?
70.
0 to 70, I agree. EA reverse would be 60. Delta H, what do we say? Positive or negative?
Positive.
I would say endo here too. Looks higher to me. So positive and negative, and y'all say 10?
Yeah.
0 to 10, I agree. And they're all kilojoules per mole, all 4 of them. All right, do we feel okay about potential energy diagrams? All right, Tiffany, come get the keys. You can unlock the computer. Cart.
Unlock the computer.
Tiffany.
Stop, bro. He's like, what's that thing?
Name. What's his name?
Where's my mom?
Oh no, we gotta do Kahoot. I hate Kahoot.
Just a short one.
Gotta use my phone.
We should do Quizlet Live.
I would appreciate if you would use your phone.
I think it's
We should
dead.
do Quizlet Live. We do that in Health Science. It's kind of fun.
I've used Quizlet Live. It's okay. I don't mind it.
I just be getting irritated because I'm competitive, especially in teams. I would get mad.
Nicknames be weird.
Oh, those of you who are out on Friday, y'all can get one of these graphs. It's a phase diagram. So if you're out on Friday, you might want one of those.
Yeah.
What's this Kahoot on? It's on this right here?
The Kahoot? No, it's on yes or Friday and today. It has like 12 questions. It's not all just like just what is your diagram.
Oh, I am so slow.
If memory serves, I designed it to help with the quiz on Thursday.
Can you exit me?
Or really tomorrow, but since we'll be here tomorrow. Can I X what out?
She is.
Really?
The code.
I didn't walk all the way over here.
For what? It's right there.
I did not want that. I was not the one.
Oh, you went to X out the code?
No. Yeah, Jake, come again. No.
She about to put autumn.
I do it.
Put autumn. Autumn day.
What is you doing? Weirdo. Oh, I'm out. Hey, I have a question.
What?
What is this? Air. Like, what kind of air?
It would be gas if it was hooked up, but it's not. Does it say air?
Why is it different?
Yeah, it say air.
Gas and
I don't know. It'd have to be. It would be air, but I don't know air of what type. None of that's connected to anything.
Pressure valve.
That'd be cool if we had oxygen. Why you put autumn Jake on? Oh no, it wouldn't, because you have to light a fire. You extra.
All right, the three of y'all are not in. Let's go. Who is S?
Me.
You're just S today.
Yeah.
What happened to Sam?
Did everybody who wanted a phase diagram worksheet from Friday get one?
Oh.
If you were not here Friday and you want one,
Do I have to turn it in?
no. We did it in class. It will be on your quiz or test
I need one.
on Thursday. You will be responsible for the material on the quiz Thursday,
Yes, ma'am.
and it's possible we may still do one more test. And if we take the test, there are like 5 questions on it.
No, put my phone.
All right, do it. I'm missing one. Who's the last one I'm missing?
Me.
Come on.
My computer is slow, like you.
Oh,
I'm not near as slow as you are.
that was mad disrespectful. You should apologize.
It's all right. She's still got to get a grade for me this semester. My memory is long.
Ooh.
Is that for me? You know, my fingers have got slipped on my computer. An A becomes a B, a B becomes a C.
Oh, no, don't
C
try to
becomes
play
a
that. I will
D.
get you fired.
You can't get me fired. You know I didn't think you can.
I'll get you fired for not giving me my right grade.
Go ahead. Think that all day long.
I ain't done. I ain't done nothing. I don't believe it.
Are you going to log in today or what?
I am. I'm putting in my name right now. Is this cherry coke? No.
Are you ready?
Oh. Okay. Yeah, y'all got good job. Why we only got 2 hours?
Did you read the question?
Obviously.
And you think I'm slow?
I got it wrong. No, you like
No.
girls laying in the bed.
All right.
Oh.
That's not bad. When you look at this, what's lower, the products or the reactants? The products. That's why it's XO.
You probably. I didn't do anything. What?
What?
I'm a guess. Yeah, you're wrong. Yeah, you wrong. Yes, you gotta go. This is what y'all did on Friday.
Is this balanced?
Oh, yeah, 'cause I didn't watch the video.
That's not even balanced.
You really think I'd put a reaction up there that's not balanced?
Oh, it's balanced.
Oh, it's not.
Here, you-
Oh. Now, is the reaction relevant?
No.
The reaction is not relevant. All right? When we talked about kinetics on Friday, what did we say about temperature?
The lowest.
The lowest temperature will be the,
Slowest.
and the highest temperature will be the fastest. So when you look at that up there, which temperature will be the slowest? Which temperature is the lowest? The 25. So it's going to be the slowest. The reaction's just there to throw you off. And then Xavier's all, is that balanced? That reaction's not balanced. I wouldn't put a reaction up there that's not balanced.
Yeah, you would. You sound like something.
Yes, I would, because Jaden believes I'm slow. Yeah, the phone before it's on my desk.
I wasn't on my phone. I had it in my hand and I dropped it on my computer.
Now, this question absolutely amazes me.
I read absorb.
Did you read the question?
Yep. No.
It says in the question, energy is absorbed. Okay? It says energy is absorbed. And people picked energy is released. Energy is released. That's a typo. It should say released. Okay? So nobody should have picked blue and nobody should have picked red because it says energy is released in the answer. It says energy is absorbed. Okay? So in order for energy to be absorbed, was delta H positive or negative? Is that the definition for endo or exo? Absorbed. Is it endo or exo? It's endo. So is endo positive or negative? Positive. Y'all got some work to do before Thursday's quiz. Y'all got some work to do before the rest of the lesson.
Why somebody pick C?
I
chose B. I want some toast. I had some gravel last night.
All right.
Somebody did pick C.
C is the activated complex. This is called the activated complex. I've not used that word because it's not important. B is the right answer. A is the reactants. Whoops. A is the reactants. D is the products. C is the activated complex, which I've not talked about. B is the only right answer. Oh, wait. All right.
All them J.
What's your
I got C out.
I told y'all to get caught up on Friday. Okay. This is why we're doing this, so that those of you who are not here Friday can hopefully get caught up. All right. You need sufficient energy, and what was the other thing?
Right orientation.
Proper orientation. Okay? So,
Which factor will decrease the rate of a reaction?
you want to increase the rate. All right. Remember, if you increase concentration, you increase rate. So decreasing it will decrease the rate. All right. That's why it's. Which one did I say? Which one will increase the rate? Increase the surface area. All right. Any of these, removing the catalyst will slow it down, decreasing the concentration, lowering the temperature. All those slow it down. All right. This is just a definition. We should all know this one. Oh. Yes. That's why we're doing this. We did it yesterday in the open to try to catch y'all up.
Yeah,
got fluid tomorrow.
It's critical
It's a triple point.
Yeah.
Okay? The triple point is when all three of them exist at equilibrium. The critical point is when no more what can exist. Once you get to the critical point, what cannot exist anymore?
Energy.
Liquid. Once you get to the critical point, liquids don't exist anymore. It's all gas. Okay? The critical pressure and the critical temperature are the last point in which a liquid can exist. You're all gas after that point. Equilibrium is the triple point.
Oh, he's on fire.
When solid changes to a liquid, gas is.
I clicked.
It's shooting down.
Think about whether you need to speed up or slow down. You know, Andy, the most fabulous thing happened on Friday when you were not here. Leah did not have anybody to talk to, and she talked to me and answered questions. It was fabulous.
hey,
She actually has a voice.
I heard somebody burnt up your counter.
Oh, the piece fell out of the bottom. Wasn't a problem. Happens regularly.
The counter got caught on flames.
Counter didn't catch on flames. The
Oh, somebody had to use the shower?
I used no. It fell out of the bottom, so the gas came out of the bottom of the Bunsen burner. So the whole bottom of the Bunsen burner was on fire.
I want to see what it looks like.
I made a video of it. I told them to turn the gas off.
No, I'm talking about the
How
shower.
fast was the water come down?
It's a 2-inch water pipe, so it's a lot.
Okay,
Right.
that is so
The water
old,
pipes
it's a
are like-
sprinkler.
Usually
Okay, I have a
half an
question.
inch.
What?
On the last day of school, if I pull it, what's gonna happen?
I'm gonna be pissed.
Should clean
We
it
can
up.
put a bucket, we can put a
I'm
tub,
pretty
Should
sure I
clean it
can
up.
get you in trouble for the start of the next
we
year.
can put a tub underneath it.
End of our
Keep
senior
down the
year.
water.
Hey, should clean it
Our
up.
senior year, we come in, we pull it with it.
And we get our bathing
We can
suit.
take a football.
Yeah.
It's gonna make a mess to clean up.
That's gonna
No.
be in the tub. That's gonna be one.
No.
When
When a solid changes to a liquid, do we have to make the particles go faster or slower? Faster. So does heat have to be added or does heat have to be removed? If you need them to go faster, you have to add heat. So is it on the left or is it on the right?
Left.
It's on the left. So if it's on the left, it's absorbed.
In the closet, that's my stuff, yes, if I fall.
Please don't touch.
Keep talking that.
Which one do all solids have?
Keep talking that stuff. You walk and talk that stuff.
Is it all of the above?
I don't know. That's what I'm asking you.
Put all of it?
Yes.
Oh.
Have all the above. So none of the answers are wrong, but D is the best answer.
I knew 2 of them was right. So
Oh,
it's
it's
not all of the above.
Any.
See, and it's below.
Means the question's in the picture.
Man, what the heck you got us doing? That's too much to read.
So don't read it.
I know this. I know it's an English class.
I don't know this.
Hey, I don't have to.
Yeah, but I don't know this. It's hard.
Hey!
All right. So what's the key in the question?
Increase.
Hey.
Because the strip is the shape of the powder.
Oh, I got it right.
So what does the strip versus the powder mean in the answers to the question? Surface area. We change the surface area. The one with the surface area that's powdered is going to dissolve much better than something that's a big, bulky, one-size shape.
If a system in equilibrium is subjected to stress, the system will be displaced. What?
Direction of stress.
What?
You're going to do this again?
I got it.
Probably Friday.
If
If not Friday, it'll be Monday.
I don't know.
Oh, no.
Hey.
All right. This is Le Chatelier's principle. If a system is subjected to a stress, it will be displaced so as to relieve the stress. It's Le Chatelier. That's the definition. Last question.
Particles in a solid move around us, are larger or rarely spread out. Let's say this is gonna be the first one.
in a liquid. The particles in a solid move around less. They're in a fixed position. All they can do is vibrate. They can't move around more, and they're not widely separated. Gases would be widely separated, not a solid.
Can we play another one?
Nope. All right. If you will, put your computers away, please, and then find your notes.
Samaria.
You beat Samaria. It's the highlight of his day, Samaria.
And you sick, so you go down pretty easy.
Oh no, I'm gonna just cough on it. Then it's over for you.
Oh no, because all you gotta do is on the breakfast. I like these. I'm still these. Can you melt these?
Can you melt what?
These.
Yeah, if you got a high enough boiling point.
Why would you tell her that?
Can't get the temperature high enough.
You gotta be the one to tell me. Don't you know you don't trust me?
That
was funny. It's about a
You've got some
He went and threw up in the trash can, or in the toilet. He says his stomach hurts. He feels terrible.
I believe that's time.
Yeah, he says he's leaving after my class, so I made him wear a mask. I don't want it.
No, nobody does. What kind of,
They should leave now. Well, it's fine.
I'm okay. I don't know if I'm gonna make it either.
I'm back.
I hate Monday. You that fast.
Hey, Cameron trying that bag over here.
I'm doing properties today and reactivity today. Once I'm done with reactivity,
I can still see.
so I can review
I see you love
Thursday.
it.
Otherwise, I think I
You are
can.
not. You are not good.
But I got to bonding and types of
Take
reactions.
care. Take care, and I was in
I'm really debating.
I'm trying to get you to notice. I hope you would. But you're gonna keep it
Yes. 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 Yes.
I'm gonna try to get
I don't want to touch you no way.
So we're not too far.
No.
She got a bag of pizza.
Well, mine.
What?
This one's stuck.
I really
Yes. They're rarely here.
Yeah.
She brought the brownies for school.
Yeah. Yeah. All right. So how can we decide if a reaction will occur? There's two methods that we're going to talk about. One we already did this semester. So can anybody tell me the one method we already used this semester to decide if a reaction will or won't occur? Put your book back. You put yours down.
What? I was playing my phone up.
I know. I'm just being cruel to you today. I know. So you put yours in your book bag. That way you won't be tempted when you get a message to check. You're fine. Oh, you put it up already? Oh, okay. So you usually have it out. That's why I asked. So when you look back at best guess, it would have been that time. So what did we do when we did balance equations? No.
Yes.
Would have been something during balance equations. No. Then we did during balance equations to decide if the reaction would occur. Put yours in your book bag in your pocket too. So,
What is it? It's still down.
anybody remember anything we did to decide if a reaction would occur? Or
How we balance?
nobody remembers?
I already
Answers
answered
no, we
that.
don't remember tell us.
We used our reference tables. We looked something up on the reference table.
That
What's the
chemical
question
diet-
again?
How do we decide if a reaction will occur?
I got you.
If it has,
I don't know what that's called.
Are you talking?
if its reactability is high.
The activity series.
Yes, the activity series. Very good, Xavier. At least you had enough sense to look. All right.
That took a lot of effort.
Right,
Really?
you need to do a table of contents.
Yeah.
All right. So we use the activity series. All right. If it was an element was above another element, remember doing that?
Sure.
Now, today, we're going to learn how to use Gibbs free energy.
Gibby.
Okay? And we're going to use a formula, delta G equals delta H minus T delta S.
Why is everything delta?
Because it's change in.
What is the, that's what delta means?
Yes, change in. Okay? So, in order to be able to use Gibbs free energy, we need to, A, review delta H, which we talked about yesterday, and we need to learn about delta S. And then we'll be ready to talk about Gibbs. Now, this is not very difficult, except this is what I was telling you about yesterday. I think I was telling Sophie, that we're not going to calculate, we're only going to do conceptually. Truthfully, it would probably be easier if we calculated, but the state has decided we're not going to calculate, we're just going to talk about it conceptually.
Is that
Okay?
T triangle S?
Yes, T for temperature and then triangle S. Okay? So, everybody caught up?
You should have some
T
acronyms
triangle
for
S.
this stuff.
Somewhat?
Acronym.
And a table of contents.
That's T triangle S.
T triangle S.
It's TAWS.
Who had a table of contents for our note?
Miss Ford,
Yeah.
Miss Hudgens.
Yeah. And it makes it a whole lot easier. Maybe you should invest in common more.
Maybe you should create your own table of contents for your notes.
Maybe I shouldn't because no.
She be catching a whole attitude.
That's why don't start with me, okay?
Seems to me you started with me when you got here today.
No, that was just when I was saying you was eating them egg biscuits. That was just
Your buddies.
I could not fix that somebody plugged up the sink and put
So
something
you
in
say,
it.
Yeah, somebody plugged up your sink
Yes, they did.
and it was an egg
I'm gonna
biscuit.
say that somebody plugged up the.
I can't fix it.
Stop eating egg biscuits. You can't fix it.
Yes, I know. It's terrible. I need to give up my egg biscuit and have it. All right, so we did this yesterday. Delta H can be positive or delta H can be negative. Now, if delta H is positive, we know that it's what?
Endo.
There you go. And if delta H is negative, it's what? Now, that's one piece that we learned yesterday. Now, we have to branch out slightly from this. Back, I don't know, probably about a week ago now, when we did the phase changes. You remember when I told you we were going to do thermochemical equations and we were going to write numbers in the equations? Okay. I did, but it's all right that you don't remember.
He didn't tell us that.
It's
So
all right.
you said that about everything she said.
It's all right.
It's A-okay. It's A-okay. 1, 2, 3, 8.
All right. So if I write this, which is a thermochemical equation, okay, you also have to be able to figure out if delta H is positive or negative, or if it's endo or exothermic, okay? Just based on where the number is. Right, Tiffany? You remember what you asked me to do for tomorrow? Not feeling any need, any desire or willingness. So, when you look at that, what would you tell me based on that equation?
It's exo.
How do you know that?
The numbers on that.
Numbers on what side? Be specific. What science word would you use? There you go.
Kilojoules.
Okay?
Everybody said kilojoules.
That's not what I want. It's a product. All right? Because the number is a product. All right? That tells us that it's exothermic and delta H is negative. Which we did way back a week ago when we talked about phase changes. Only we wrote plus heat, then we wrote plus heat, and if heat was on the product side, we said it was endothermic, or exothermic, sorry. We don't actually have to write a number because I just made that number up. I don't have any idea what it is. If it says plus heat or plus energy on the product side, it's exothermic. If the number or the heat or the energy is a reactant, it would tell us what? David. If the heat or the energy, I want you to hush. Most people understand when I'm talking and I say their name. It's a secret.
I probably won't understand you after that. Continue.
So if I have the heat or the energy is a reactant, that tells you it's a what? Everybody have this? So if I write something like energy plus H2 plus I2 goes to 2HI. What is this supposed to tell us?
So the left.
It's on this side, so it's a what?
Endo.
It's a reactant. So that tells us it's endo. And so delta H would be what?
Positive.
Delta H would be positive. Okay? You don't always have to get a number. It could just say plus heat. It could just say plus energy. Okay? Some equations might be lazy that way and just say plus heat or plus energy. Does that make sense? Sometimes it'll give you an actual number. Sometimes it won't. Sometimes it won't put the number in at all. It'll just give you delta H equals a positive or a negative number. They can do it either way. Are you with me on that part from yesterday? Marissa, are you with me? A little?
Maybe talk for about
Okay. Because we're going to have to be able to figure out from the equations if they're positive or negative numbers. That's the piece we got to be able to get. So if I write an equation, like, I just make one up, and I say, I don't know, KClO3 goes to 2KCl plus O2 plus energy. Can you tell me if that's endo or exothermic?
Yeah.
Shh, not you. Marissa.
What is that?
Why is it exo? Okay, would it be positive or negative then? Yes, you got it if you can answer those two questions. Okay. Everybody with Marissa on how to do that?
No.
What didn't you get, Jade?
How do you know if it's negative or positive?
Can you tell me if this is endo or exo looking at that equation that I just wrote?
No.
All right, where is the energy? Is it a reactant or is it a product?
It is a
Okay, so if it's a product, it's what? It's exo. Now, anytime it's a product, you got to learn a product means it's what? It's exo, okay? Now, you with me on that part? A product is exo. A reactant is what? Okay, now, this is the part people don't like. What color am I?
You should write in that little teal color right there.
All right, you got to memorize this part. Anytime it's endothermic, delta H has what sign? Anytime it's endothermic, delta H has what sign? It's positive. Anytime it's exothermic, delta H has what sign? You have to memorize that. Okay? There's no way around it. This is the downside to this topic. Delta H has two positive negatives. Delta S has two positive negatives. And delta G has two positive negatives. So everything has a positive and negative. All right? Now, the second thing we're going to do. Entropy. Entropy is disorder. So every time you read the word entropy, substitute the word disorder, and you can answer the question. Okay? Entropy is disorder. Some of you have rooms that have very low entropy. Some of you have rooms that have very high entropy. Who has a neat bedroom? Anybody in the room? You have low entropy. Okay? How many of y'all's bedrooms are pigsties? You have high entropy in your room. Okay? I'm not talking about dirty like you got food everywhere. I'm just talking about clothes are on the floor. You got high entropy. Okay? It's high entropy. Okay? High disorder in your room. Things are just everywhere. I'm not talking about y'all got sticky peanut butter on the windowsills because you're just a slob and you're not middle schooler who can't pick up. There. That's high entropy. Okay? Now think about it. Solids, liquids, and gases. Which state will have, Justice, you playing on your phone? Good. Solids, liquids, and gases. Which one will have the greatest entropy? Think about their arrangements. I heard the right answer, but I heard solids, liquids, and gas is the answer. So clearly one of them has the right answer. Gas, okay? A gas has the most entropy. Okay? So that means a solid has the least entropy. Which means liquid's going to sit in the middle. Okay? Now, the problem we have is, before we can apply this to balanced equations, which we're going to do in a second, is we have to add in a state, sort of, called aqueous, which we talked about back when we did equations. What does aqueous mean again? Anybody remember?
Does it got something to do with water?
It does.
Okay, it's very liquidy.
Very liquidy, not quite.
The movement?
Mm-hmm.
Similar properties.
When we did chemical reactions, with the exception of water itself, everything that you guys drink is aqueous.
It's wet.
Liquid?
Water is liquid.
You got calories?
It does have calories, so I'm sure you of that.
It's
Properties similar to water.
We got bubbles.
Carbonation.
aqueous. I don't know.
Aqueous means dissolved in water.
Wait.
So when you have milk,
Aqueous?
aqueous means dissolved in water. So if you have milk, that's milk fat dissolved in water. Kool-Aid is sugar and the whatever flavor you have dissolved in water. Pepsi, soft drinks, carbonation, flavoring, sugar dissolved in water. Whatever drink you drink, other than plain water, is something dissolved in water. Okay? So where is aqueous going to fit in this disorder line we have? Is it going to be between gas and liquid or between liquid and solid?
Between liquid and solid.
Liquid and gas.
Yeah.
Yep. Gas first. It's the greatest. Then aqueous. Then liquid. Then solid. Okay? So a gas is always going to be the most because its particles are the most, has the most speed, the farthest apart, so they're always going to have the most disorder. And the solid is always going to have the least because they have that fixed geometric pattern. But the liquid and the aqueous are both in the liquid state, but the aqueous has stuff dissolved in it. Does the liquid have stuff dissolved in it?
No.
No, so it's going to have more disorder than a liquid does because this one has crap dissolved in it, so that's going to have more disorder than the liquid does. Dissolved? Do you remember talking about solute and solvent back in middle school? Have you ever made Kool-Aid? When the sugar and the mix dissolve in the water and then you stir it up and it goes away and you can't see it, but you can still taste it, that's dissolved. You can't see it. Yeah, when it's sitting on the bottom, it's not dissolved. Okay? All right, everybody caught up with the notes? All right, so how is this going to work? We want to be able to find whether delta S or the entropy is increasing or decreasing in a balanced equation. So just like enthalpy, which was the delta H, entropy can be positive or negative also. Entropy.
What's delta S? What's that sound?
Entropy. So what we're doing right now. Delta S is entropy. Okay. This is increasing entropy. And this is decreasing.
They don't look bad on you though. Right, they curve in on Zolio. And they don't touch back there.
Decreasing entropy.
Can I borrow a calculator?
For what?
To do a calculator? The calculator?
You got a phone. You're not doing anything weird on the lab.
I know, but still, I don't want to use my phone calculator.
Oh, you bring it back third period.
Mm-hmm.
Go ahead.
Next door.
Right.
All right.
Next door where?
I'm in
It's
Phillips.
Phillips.
Oh, yeah, go ahead.
See?
Don't break it over there.
Tell Zoe I said hey, and then she
Tell Zoe I gotta put her on.
And why are you wearing a hat and those sunglasses in my
Wow,
room?
why would you tell her? You got on the
Don't
glasses.
have to do nothing you tell me to do.
You a brat. Oh my god.
Okay. So, how are we going to use this to figure out entropy? So, let's say I take that same equation I had on the board just a second ago. Because we're going to start putting states in equations next week. All right. Now, if you three over there can't be quiet, you're not going to be sitting alone there tomorrow.
I wasn't even talking.
No, you were not at the moment. At the moment.
Writing an equation on the board.
Yes, and I'm tired of listening to you talk.
Talking.
You back talk me one more time, and tomorrow you're going to find yourself not in my room.
We're having a conversation.
Who's having a conversation?
We are. That's how conversations work.
No, we're not. You're just being rude.
I'm not being rude. We're talking right now.
No, we're not.
Okay.
Now, when you look at the equation, and I'll even go ahead and balance it, we want to figure out if entropy is increasing or decreasing. What do you want? I just sent one with Mackenzie. You can't share?
I'm not sure. Come on, Miss Wall. I'm calculators on me. Don't be greedy. Jesus. Come on. Share.
18 days. Now, when you look at the equation that's on the board, okay, you've got solids changing to what state? Okay, so you're only looking here to see that you have a solid changing into a Zoe, go away, into a gas. Okay, so if a solid is changing to a gas, is the entropy increasing or decreasing if you're changing from a solid to a gas?
Decreasing.
Okay. I hear increasing and I hear decreasing.
Increasing.
All right. It's increasing. Your disorder is increasing. Remember, substitute in the word disorder for entropy, and it makes it easier to answer the question. So your disorder is increasing. Okay? So, if disorder is increasing, delta S is increasing. So is it positive or is it negative? It's positive. Does that make sense? Yes or no? I got some nodding. I'm going to do more. I'm just trying to see if you understand what I'm trying to get at. Okay, you're checking the states. You're not looking at any of the compounds. You're looking at the states in the equation. Okay? Does everyone have what they want off the board? It's going to be written. You're not going to have to figure that out. It's going to be written in the equation. Okay? Stop. Put your hands down. All right. Does everybody have what they need? All right. So let's say that you have one that goes from.
Yes, solid. Yes,
Okay. We're going to do one that goes from a gas to a solid.
Yes, to liquid.
It's a solid plus. No, that'd be CO2. Yeah, and that one would already be balanced. All right, so what would happen here? What do you start with on this side? All right, you have a solid, but is that important? No, because you start with what here? Got a gas, and it changes into a what? Into a solid. All right, so what's happening there? Okay, the entropy decreases.
How do you know which reactant to use?
It doesn't matter. You're just looking at the states. Okay, you don't have to look at all of them. You're looking for the one that's different. Okay, if they're the same on both sides, you don't have to look at the one that's the same. Okay, now what happens if you have one like this? I'm going to give you one that they're all the same. All right, so delta H was what if it was decreasing? We didn't finish that. What is it if it's decreasing? Delta H would have what sign? Got it. All right, so what happens if they're all gases? What do you do then if they're all gases?
Nothing.
Oh, we gotta do something that y'all know.
No balance.
Look at the numbers.
Look at what number?
The balance.
Okay, so we're gonna look at the balance numbers. That is correct. What are we looking for in the balance numbers?
Which one's big?
Not which one's bigger. You're on the right track.
The
Mm-mm.
big number.
Mm-mm. Not just the big number.
Right, where you at?
I said, what are we going to do if they're all gases? And they said, look at the numbers. And I said, yes. What are we going to do with the numbers, though? And they said, look at the big number. And I said, no. Not change them. You're only looking at the numbers. But what are we doing with the numbers? Change them how?
Increasing.
What if I put an equal sign there?
I don't know. Go ahead and hit the arrow.
How many are over here?
Gas equals gas.
And how many are over here?
1.
You have the right idea, but the wrong numbers. How'd you get 6? That's how you're getting it wrong. You're not multiplying. You're not using the subscripts.
Oh, 16.
How are you calculating?
4 and 2.
There you go. There's 4 moles and there's 2 moles. Okay? How do we get 4 moles? There's 1 here and there's 3 there. So there's 4 moles on this side and there's how many moles on that side? 2. Okay? So if you have 4 moles on the left and you have 2 moles on the right, what's happening to your disorder? Any of y'all ever babysat before?
No.
Really? Yeah, think about it. You got 4 kids you're chasing around and you drop to 2 kids. What happens to your disorder?
It is lower.
It gets a lot lower. Okay? So delta S does what? It decreases, right? So is it positive or negative?
Negative.
It's negative. All right. Do we need to do another one? You think you got it? All right, let's practice. That's a small one. And I actually have the holes punched to the wrong side of this. We're doing the back side. We're doing the side that says entropy. All right, I can maybe one this smart. All right, you're telling me increase or decrease? Tell me increase or decrease? There's one for Tiffany in your way.
What's the other one for?
The back side? That's after we do gives. That's right. Good.
Hey, Sam.
Ecology.
Hey. Don't figure out a way I can somehow have that busy.
Yeah.
But what? And not be my name.
I'm figuring out how to do that.
Thank you, Larry.
What's her language?
That's what see, I didn't pick up on it.
I don't know if I'm looking at it.
Maybe it wasn't on. Oh, it was. It was. There's no someone.
Yes, there. No.
You?
Yeah.
Or his friends.
Wow. Great stuff. Right.
How do you get 8 more?
That's one way I teach them teachers. Right.
What did you
Don't tell
But
them.
that's not it.
Yes.
No.
You got what you get for 8?
I got increase.
In charge.
And don't he'll see this?
I don't know.
I was thinking.
I have no idea.
What about 9?
I ain't in charge.
So I don't know how you do it.
You lose the number.
Oh, you look at what's different, very solid.
Oh.
That's well.
Yep.
What if they're equal?
For what?
What if they're equal?
Well, what happened?
It's an increase, right?
What do you think?
Let's get this thing.
Oh,
So, same.
Have no effect.
What should be?
Right. Right, because she said.
Well, let me go.
You're not getting a hug today. You might not get a hug for several days.
why not?
So, you just threw up. Give me a break.
You gonna make me wear one of these every day?
I only have 2. All right.
The first one is.
All right. Has everybody had a chance to try them, or are we still working? Where are we at? You only did some of them. Keep going.
All right, I got 4 left for 5.
Okay.
It's the same.
We did the back.
I did all of them.
No. The back is Gibbs. We can't do the back yet. Get ready to do the back.
Oh, we ain't got time to do this.
Yes, we have time. Gibbs is not hard.
Okay.
This is where those of you who were terrible at positive, negative numbers in math class, it really comes out. All right, can we look at them?
It's funny.
So, number 1, what happens if you go from a solid to a gas? It increases. Liquid to gas? Liquid to solid. Decrease. Gas, what do we do here? Why did it increase?
Decrease.
It went from 4 to 2. It's a decrease. I thought y'all said increase for a minute. All right, so solid to aqueous does what? It increases. What happens in 5 from solid to liquid? It increases. 6, solid to gas. Increases. All right, 7, aqueous to liquid. It decreases. All right, now would we be okay with putting in positive and negative numbers?
No.
So any place you put increase, you would write what sign in a few minutes? Positive, and every place you put decrease, you put what sign in a few minutes? Negative. We're okay with that, right?
Yeah.
Just checking. All right, so number 8, you put what? All right, positive or increase. Number 9, All right, because is everybody okay with what y'all were arguing about a minute ago? These are all gases. How many moles are right here? 2. 1 plus 1 is 2, and 2. So you can't say increase or decrease. You can say no effect there. All right. From there, number 10, you have what? You got aqueous to a solid. Decrease. Number 11, you have all gases. You go 2 to 5. So it's what? 2 to 5. Increase.
Wait, on what?
Number 11.
Oh, yeah.
All right. Number 12, we have how many to how many? 5 to 2 would be decrease. Number 13. Would we be looking at the moles? No, we're looking at the states. We go from what to what? Aqueous to liquid, which would be decrease. And then 14, we have all gases, so we're looking at the what again? There's no effect because we're looking at the moles. And 15, we go from gas to liquid, so it will be decrease. Everybody okay with how to increase or decrease with entropy?
No.
All right.
Really?
What? Which one? Okay. All right. The last thing we want to do today is Gibbs. We got time. What are you talking about? We ain't got time.
Do this on a coffee. We have
All right.
for the rest of the time.
Gibbs free energy. Tells if a reaction is spontaneous or non-spontaneous. Now, what does it mean to be spontaneous? All right, it happens on its own. Okay? It happens without help. So when I talked about putting sodium metal in water and it exploded, okay, that is a spontaneous reaction. When you put sugar in water, what happens to the sugar?
So,
Can you stop it from happening?
yeah.
That is a spontaneous reaction. It's still going to dissolve. You can leave it sitting there overnight, it will dissolve. You cannot stop it.
So what about like?
Yes.
So you know, like that stuff that's still left at the bottom of like when you make tea.
Yes. Now, sometimes it becomes saturated, which is a different concept. We're going to talk about that hopefully either late next week or start of the following week. Okay, it will be before the exam, but it'll be one of the last concepts we talk about before you actually test.
How many questions is on this?
40. Now, if a reaction is, change colors here.
It's a 2-hour one.
Yes.
Yes. Wait.
All right, a spontaneous reaction means delta G is negative. A non-spontaneous reaction means delta G is positive. Now, this is what I was telling Sophie yesterday. You can actually have delta G equal to 0, and that means you're at equilibrium. But because we're not actually calculating delta G, are we ever going to get a delta G equal to 0? No, we're only going to focus on the top two because we're doing this conceptually. We're never going to worry about the bottom one. Okay? The state wants us to do it conceptually, so we're not going to do it with math. Okay? All right, does everybody have the rules? Yes? Okay. So, if we have a reaction like, let me see, let me give it a real one so that I don't make up a bunch of crap that's stupid. I'm even going to lay it out like your quiz. All right, I'm going to want to know endo or exo. I'm going to want to know delta H. I'm going to want to know increase or decrease in entropy. I'm going to want to know delta S's sign. I'm going to want to know spontaneous or non-spontaneous. And I'm going to want to know delta G sign. Okay? That's how your quiz is going to be laid out.
What, it's gonna have like 5?
No, this will be Friday's quiz.
So we got Thursday and Friday quiz?
Thursday and Friday?
Mhm.
Okay.
Oh, you
So what's
can
the
get
Thursday quiz?
Collision theory. It'd be like the Kahoot we did.
I got sick. So it's starting from Friday to Thursday, and that's the week Friday.
All right, so how will we figure out? I'm thinking I've got examples of this, so I don't have to keep writing out or making up examples. So the next one I can look up. So when you look at this, how will you decide if it's endo or exothermic? What do you look for in the equation to decide this? All right, which side the energy's on. So which side is the energy on? All right, so you look up here and you say this right here is a reactant. So once you know it's a reactant, you know it's what? You know it's endo. Is everybody okay with that piece? Okay? So we know it's endo. Now, if you know it's endo, what do you know about delta H? Is it positive or is it negative? It's positive. Now, to answer Jade's question from earlier, you have to know this based on endo. That's the piece you have to memorize. Okay? There's no getting around that. You have to memorize that endothermic is positive and exothermic is negative. That's just gross memorization. I can't teach you that piece. Now, increasing and decreasing entropies. I left the states out. Let me put the states in. You probably remember them doing them on the worksheet because I've written this equation multiple times, but let me put them in. All right. So, can I just look at the states? No. So what do we look at if all the states are gases? The moles. So how many moles do I have? All right, it's 4 moles to 2. So what happens? Got it. 4 to 2 tells me it decreases. So what do I know about my delta S? It's a negative because you said it was decreasing. Are we okay with decreasing and delta S is negative? Okay. That we should be able to do based on what we've already learned today. Everybody there? Here's the new piece. Okay? We're taking the formula that you guys were given on the very first slide for Gibbs. Delta G equals delta H minus T delta S. Now, we're not plugging in any numbers. We're using your math skills. Okay? What sign did you just tell me delta S was? Sorry, delta H was. That's first. You said it was positive. So I'm going to put a little plus sign there. Subtract. I don't care what the temperature is because we don't have one.
40.
All right. What did you say delta S was? Got it. Now, what happens when you multiply? Because this means multiply in math class, right? What's a minus times a minus? This does what? They add, right? So what's a positive plus a positive?
2 positive.
So delta G is a positive. So if it's a positive, are we spontaneous or non-spontaneous? We are non-spontaneous. Questions? Yes? No? We're going to do another one before we yell out homework over there.
It's time to go.
It's not time to go. I have 9 minutes.
It's just time to do it in class.
You won't stop for that?
Let me call for you. We got a lead pencil.
There are no lead pencils in this room.
The cars are 500, so.
Or covering graphite.
You got my pen.
Hey, Stephanie.
So,
You got my pen.
no, bro. Give me that shot. Right.
Only question are where are my gives free energy. All right. So here's an equation. Here's a different equation. So I don't have the exact same equation up there. Because I struggle to make these up off my head so they're legit and not just stupid numbers. So these are real numbers. All right, so if we look at the equation, what can you tell me?
Energy is on the reactant side.
All right, the energy's on the reactant side, so it's what?
Endo.
All right, this tells us it's endo. So it's what?
Positive.
Okay. What can you tell me about the states?
It's
They're all the same. So we go from how many moles on this side?
decrease.
3 to 2. So it's a decrease. So delta S is what? All right, so this ought to be the same as what we just did. All right, so delta G equals delta H minus T delta S. So delta H has what sign? Minus. Delta S is what? What did these two do? Okay. And what did these two pluses do? So it's positive, which tells us what? It's non-spontaneous. All right, let's see if my next one's different. Should be. Everybody okay with how to do that? All right, let's try one that's different. Yeah, this one should be different. Just write the equation down. You don't need to write all that crap at the top. All right, just write the equation at the bottom. Just so you have a different example. Because I want you to have one of each in your notebook.
I don't even know T.
All right, so when you look at the equation, what do you notice first is different about this one and the last two?
Or no, the reaction and the product on.
It's
Hang on, let Justice finish.
The product on the left.
All right, the products are on the left side. There's how many?
One.
Okay, they're all gases, so there's how many in terms of moles?
Oh, two.
2. All right, how many are on the right side?
Yeah, 4.
4. Okay, so we're going from 2 to 4 this time. All right, so Justice says we're going from 2 moles to, let me change colors. 2 moles to 4 moles. All right, what were you going to say, Xavier?
Huh?
I said, what were you going to say? It was different.
Oh, no.
You weren't going to say anything's different? Somebody over here was going to say something's different. Who was going to say something's different about this equation? It was over here. Somebody tell me something's different about this one than the last one.
Decomposition.
All right, it is decomposition. All right, what else?
It's a spontaneous.
All right, how are we going to know that?
Because I already did it.
What else is different in the equation? All right, let's start with, let's tell me what's this tell us? What's this tell us?
It's on the right side.
All right, it's a product. So that tells us what about it?
Negative and exothermic.
It's exothermic. So if it's exothermic, delta H is what? It's negative. Everybody okay with that lead? If we go from 2 to 4, what happens to our entropy? It increases. So that means delta S is what? Positive. So when we plug into delta G equals delta H minus T delta S, delta H has what sign? Negative minus a positive. What happens when you multiply a negative and a positive? What happens when you add two negatives? You get a negative. So if you get a negative, is it spontaneous or non-spontaneous? It's spontaneous. Okay? Now, I want you for homework tonight. Homework, I know. What am I reading?
You only giving us homework.
You got 2 days. You got Wednesday off. I want you to do the chart, and I want you to do 1 through 6. I don't care about 7, 8, 9, and 10 because it's calculating, and you're not going to be asked to calculate. Now, I also want you to do. I know, what am I thinking now? 13 multiple choice questions. Because I haven't decided if the quiz is going to be for response or multiple choice. I'm debating. Fridays is for response. And we're going to learn how to do some math on Thursday. Those of you who like math, we're going to do that on Thursday. It's easy math, though, so Tiffany just stop complaining over there. You'll like this. It's not hard. The hardest part is using a calculator.
So it should be easy to catch up, right?
I think so. If you actually do what you're supposed to do. The problem is, will you do what you're supposed to do? Therein lies the question. And so many of you just don't.